Well, unlike the U.S. Navy in World War II, I was not victorious in the war with this radio. And I'll explain why I said that in a minute. But what I have decided is that this radio is not worth restoring. Now, part of the reason for that is it's a cheap radio. I mean, 5-tube super hits with no real interesting features or cabinets or history or anything, or a dime a dozen. Well, a little more than that, but they're cheap. And frankly, I think what I'm going to do is part out this set. Part of the reason I'm going to do that is I have discovered that both of the IF transformers appear to be good, and those are rather useful if you ever have a problem, because you can't buy these anymore. At least I haven't found a good source. The tubes are not that expensive, but they would be of some use if we're working on a similar set. But as you'll see in a minute, some of the things that I've discovered about this set. One, it doesn't have a dynamic speaker, even though that's what the schematic says. So that was probably a production change. Second, the primary of the output transformer is open, and I'll show you how I determined that in a little bit from these resistance measurements. There are some other issues with this unit. Quite frankly, if the output transformer were good and if the speaker were in better shape, I would probably continue with this radio, especially because it has some significance in that it's one of the few radios built in Texas during this period. But let me tell you where I will go, or where I would have gone if I had decided to continue with this. First, I would have replaced the cord with a cord that had a proper polarized plug, and I'll show you one of those in a minute. I would also have replaced any of the line bypass capacitors, and I'll point those out on the schematic in a minute, with safety capacitors. Now, the advantage of safety capacitors is when anything goes wrong with the capacitor, either because there's a big surge on the line, a lot of capacitors get knocked out because of a high voltage surge that comes down the power line from outside the home, maybe lightning or whatever, into the radio and shorts out the bypass capacitor. Let me show you what I'm talking about here on the schematic. If you look at C19, you'll notice that it is connected from the one side of the power line directly to the chassis, and then the chassis, of course, is connected to one side of the power switch. Well, another thing that I discovered is the power switch in this radio is bad, which means that because it's attached to the volume control, I would have to replace the volume control, that's this resistor here, at the same time. So by the time I added up all of the things that would need replacement, including a speaker, an output transformer, and so on, I have decided not to go forward with this. But once again, had I gone forward with it, one of the things that I would have put in it is a fuse. And I'm going to talk about fusing in a future episode, because I think that the best way to protect both the radio as well as yourself is to put a proper size fuse in all of these old radios. Also, I would have rewired the input circuit, the AC input circuit, so that instead of switching to ground, I would have put the switch in the hot side, and then I would have made sure that when I did the polarized plug, that the neutral side of the polarized plug, which is the wider spade, was connected to the chassis, so that when the set is turned off, there is absolutely no possibility of there being current in this circuit. Now, of course, there's no such thing in life as absolutely But barring something like a shorted power line or something like that, this wire, for example, shorted to some components inside or whatever, which is unlikely. When you turn it off, all the power is removed. One of the problems with this system is, since this can be reversed, when you turn off power, this side of the line is no longer connected to, the chassis is no longer connected to anything. It just floats. Well, if this side is hot, which it's connected all the time, that means that there are places in this radio where you can contact high voltage and there's no return path. That can be a dangerous situation. Well, I won't tell that story. There's an electrician that apparently didn't understand that problem once that worked for me, or contractor that worked for me. And he shocked himself a number of times, and I finally sent him away because he seemed to not understand that if you don't have the neutral side neutralized by connecting back to a ground, usually through the power transformer out on the street, then the whole electrical system becomes dangerous. I won't go into it more than that. But nonetheless, replace these with safety capacitors, rewire the plug so that the neutral goes directly to ground and the hot side goes through the switch. Now, in addition to that, what I would have done is replaced the paper capacitors in this set with good modern, in this case these are 630 volt plastic caps. And this is a good example of some people that ask questions about outside foil. Now, these capacitors effectively have an outside foil issue because one of these leads will produce more interference, more noise pickup than the other. So obviously you want the one that tends to pick up noise to be the one connected to ground. So as I pointed out in an earlier video, the lead that's connected to the outside foil in essence forms a little shield around the capacitor, and you want that shield to be connected to ground. So if this is the proper lead for that outside foil, you want that connected to ground. Maybe in a future video I'll show you some ways to do that. Mr. Carlson uses an oscilloscope, but you can use a signal tracer or just a high gain amplifier, or if you have a working radio with a volume control, you can actually use the volume control to find this. But I'll talk about that in a future video to find the outside foil. Unfortunately, these capacitors are not marked, and as far as I know, there's no guarantee that even if you figure out which one is the outside foil on one, that will necessarily be consistent through an entire run. Finally, on capacitors, my suggestion is that you not go out, if you're starting out, don't go out and buy a bunch of equipment, don't go out and buy a bunch of parts. Buy enough for the radio you're working on and a few extra of each, assuming that you're thinking of doing some in the future. The few extra of each are so that you have a small stock on hand, but don't go out and buy one of those $100 capacitor assortments. If you want to buy a few extra capacitors in order to spread the shipping cost over a few more units, that's a good idea. So if I were starting out, what I would do is I would buy one replacement capacitor for each capacitor in this set. Sometimes some of those will be duplicates, of course, in which case you might need to buy 2 or 3 of the same value. Then I would double that order. These are not that expensive. That would mean then that I had on hand a complete second set of capacitors here. There's 2 reasons for that. One is, if you're going to do future radios, you already have a few on hand. Second, you may discover that one of these capacitors you bought is bad. I have found that there is a small, probably about a 1% chance that one of these capacitors, when put under voltage, will fail. And so you do want to test them before you put them in the set. We'll talk about testing capacitors in a future episode. At any rate, let me switch now. Oh, by the way, the resistance readings that I took with this radio, I took with all three of these multimeters, partly so that if one of them wasn't quite calibrated, it would show up as a discrepancy with the other two. But what I've discovered is what I suspected, and that is this little $8 multimeter worked fine. It's a little less convenient because you do have to switch the ohm scale to get the correct reading, but nonetheless, for $8, that's all we've spent so far. One last thing too, I took the antenna off. It's just a single screw in the back here, mainly so I could get to these tubes while doing some testing. So let me now tell you what I found from all that resistance testing, or what I surmised from it, and then wrap this up. So I wrote down my conclusions based on the resistance readings that I took and some supplementary readings that I will show you how I made in just a minute. A series of things about what is good and what is not good about this radio. So let me zoom in on this. Maybe the contrast will improve a little bit. Yeah, that's a little better. And tell you how I came to these conclusions. Well, first, maybe just a little bit further. That's centered. The first thing I concluded is that there is good filament continuity. And what I mean by that is that if you look at this portion of the schematic, if you measure, first you have to have all the tubes plugged in for this to work. If you measure from this pin, which is pin 2 of the 35Z5, to chassis ground, what you will read is the value of this filament, then the 50L6 filament, the 12SK7 filament, 12SA7, and finally 12SQ7. This is what is known as a series string filament. In other words, each of the filaments are wired in series, like old Christmas lights used to be. Well, of course, one of the problems is, just like the old Christmas lights, if one of these filaments burns out, none of them light up. So unlike a set with a 6-volt filament transformer, where if one of the filaments burned out, you just look in the back of the set and see which one isn't glowing orange. With a series filament set, the only way to tell that the filaments are good is if you turn the unit on, which of course I didn't do, and they all glow, well, that tells you that it was good. But if they don't glow, they'll all be dark and you can't tell which one is bad. So what I did is a resistance reading from pin 2 of the 35Z5 to ground, and I got about 120 ohms. Maybe in some future video I'll give you an idea of what the ohms, what the DC resistance should be of these various filaments. For this particular current, that is the series current that these tubes were designed to operate at, in general, the DC resistance is just a little bit more than 2/3 of the filament value. So, for example, a 50-volt tube, you take 2/3 of that and you get about 30-something volts. Well, I think the 50L6 actually measures about 34 ohms. So, about 2/3 of the voltage value is the resistance of the filament. So basically, I got about 120 ohms to ground. The next thing is there's a bad power switch. Well, that I determined by simply hooking the ohm meter to this wire coming in from the outside. Now remember, I had cut the plug off, so it was just a wire. To this wire, and the other side to ground, and then I just turned the set on and off. Well, it makes no difference. The switch is completely open. I suspect that's why this set was taken out of service. But at any rate, it is open. The next thing is good electrolytic leakage. Now, what I'm talking about there is these two electrolytics in the power supply are not excessively leaky, at least at the low voltage that this multimeter operates. Now, if I put this under load, I might discover that there's excessive leakage. But at least I know they're not shorted. How do I know that? Well, if you follow this line up to pin 4 of the 50L6, and then we look at what we read on pin 4 of the 50L6, 32 megohms, it's clear that the electrolytics are not shorted, nor do they leak very much at the low voltage. The next thing is open output transformer primary. Now, let me tell you what I'm talking about there. You'll notice that the plate of the 50L6, that's the terminal at the top. By the way, this large T-shaped symbol, upside down T, is the plate. That comes out on pin 3. So pin 3 of the 50L6 goes through the primary of the output transformer, and then notice that the other end of it goes to pin 4. So if you measure from pin 3 to pin 4 of the 50L6, you should get, depending on the transformer, 100 ohms or so. In some transformers it's a little less, in some it's a fair amount more, but nonetheless you should read a resistance. Well, between 3 and 4 in this radio, I get infinity. So it's clearly open primary. The next thing is good output transformer secondary. Now, that I measured by going across this side of the speaker. Now, I did that inside the set. Let me show you what that looks like. Turn this slightly. You will see down in here there are two terminals that are easily accessible, one here and one over there. If you put the ohm meter across this, what you are measuring is from this point to this point. Now, it's possible that the speaker could be open and the transformer good. It's possible that the transformer could be open and the speaker is good, or both. But you should get a low resistance reading. I think I got 6 ohms or 5 ohms between these 2 points. Since I already know the transformer is bad, it really didn't matter, and also this is a pretty trashy speaker that's in there. Had it been a dynamic speaker, and I'll talk about that a little bit more later, I would have probably disconnected to see whether the speaker was good or not. But frankly, by the time I got this far, I had figured out that this radio isn't worth restoring. So that's in my opinion. So good output transformer secondary. A low cathode resistor on the 50L6. What we're talking about there is, this is the cathode of the 50L6. I realize that's out of the shot, sorry. This is the cathode of the 50L6, and you notice that there's a resistor that goes to ground. There's also a capacitor from that point that goes to ground as well. That resistor in the parts list is listed at 150 ohms, so that's what we should read from pin 8 to ground of the 50L6, and you notice that pin 8 we read 128 ohms, which is just barely within the 20% tolerance. So it's probably acceptable, but a little bit low. The next thing is a good pilot light. Well, how did I determine that? Well, I pulled the 35Z5 from its socket, and then I measured from pins 2 to 3. Notice that pin 2 is connected to one side of the pilot light and 3 to the other. And I got about 120 ohms, which is about right for this type of pilot light. It's a PM, not a dynamic speaker. How did I determine that? Well, there should be a field coil. You notice it says here a 400 ohm field coil. Well, if you measure from pin 8 of the 35Z5 up to pin 4 of the 50L6, in other words, basically across this, what's supposed to be a field coil, you don't read 450 ohms, you read a lot higher than that. And there's no field coil in the loudspeaker. Physically, you would see that as another pair of connections to the loudspeaker. Remember, one pair goes to the voice coil from the transformer, but there should have been a second set of wires from the power supply, one here and one there, that go up to a field coil. Now, what this means is that this particular radio once had a field coil, but for some reason this one does not. And the speaker it does have, unlike the nice field coil speakers, which are worth saving, this is just an ordinary, what is called a PM, for permanent magnet speaker. And those really have little, if any, vintage restoration value. So obviously field change was made there as well. A field change, I mean an engineering change in the during production. R4 reads 240K, not 200K. Now R4 is this resistor right here. Notice that one end is pin 4 of the 50L6 and the other end is pin 6 of the 12SQ7. So if you measure between this plate and this plate, you are in essence measuring the value of that resistor. And it read about, what did I say, 240K, where the parts list said it should be 200K. So it's a little bit high. Next thing is good second IF transformer primary. I determined that by going between pin 4 of the 12SQ7 and ground. Now let me explain what I mean by that. If this transformer were open, pin 4 would read infinity. There'd be no conduction path because it has to go through this transformer first. Now, if this capacitor were shorted, you'd also get a conduction path. But what I read from pin 4 to ground on the 12SQ7 is 570K. In the parts list, R8 is 50K, and R9, the volume control, is 500K. So if you add those two up, they're in series, you should read from pin 4 about 550K plus or minus 10 or 20%. So I read 570K, that's certainly acceptable, and it proves that the second IF transformer secondary is good. Now, how did I do the IF transformer primary? Well, the primary is from pin 8 of the 12SK7 down to pin 4 of the 50L6. Follow that through, comes down here to B+. B+ is connected directly to pin 4. So between this point and pin 4, I read, I think it's about 12 ohms. Next, good first IF transformer primary, that's this winding right here. And you can measure that by going from pin 3, once again, all the way over to pin 4 of the 50L6. How about the secondary? Well, the secondary is a little tricky. It goes from pin 4 through the transformer and down to this line, which is called the AVC line for automatic volume control. Maybe we'll talk about that sometime in the future. Then, from the AVC line, it goes up, goes through this loop antenna, and comes out on pin 6 of the 12SA7. So, if you measure from pin 6 of the 12SA7 to pin 4 of the 12SK7, you can, and you get a low ohms reading, then you know that the secondary of the 12SK7 is good, of the first IF transformer is good. Okay, well, that's probably enough to illustrate the method and the reasons that I concluded that while this radio does seem to have good IF transformers, it does not have a good output transformer. It has a bad power switch. Frankly, it's a cheap radio, has a bad speaker. At least a trashed speaker would need to be reconed. And at the end of the day, if I did all of that, put about, I don't know, $50 or $75 worth of parts and $100 or $150 worth of labor into it, I'd have a radio worth $10. So, at any rate, what I was trying to do was use this radio as a guinea pig, or whatever you want to call it, test case. And I hope that what this has shown is the way that you can use resistance readings. First, in an earlier episode, we talked about how to do these readings. And then here, how to use those readings to draw conclusions about the radio itself. So I hope you've enjoyed this series. I think I'm going to discontinue the Frugal Repairman series for now and pick it up possibly in the future, but with a different radio that is more worth the time and money that it would take to restore it.